Can you authorize me for recording? I'm gonna try it out here just to see. I don't even know.
Oh, sure. I'll make you a host. There you go. Glad you were able to make it.
Good to see you as well. How's everything going at NASA?
It's been going pretty well. Yeah, just lots to learn.
Better than what's going on at Boeing.
Well, hopefully they're launching this week.
Yeah, I know, but they still have that capital screwed up.
Oh,
Capital still messed up. I would have fired Boeing a long time ago. It's too prolific.
Well, I did play with me.
I'm glad you made it.
Yes, thank you.
So it's nice to meet you finally in person.
We've met before.
Oh, you came to our meeting.
I think so, yeah, that's quite a while ago, so.
Oh, it has been a while, yeah.
But, yeah, I think we've met a couple different places, really. So you have the presentation ready on your computer?
I do.
As well, so yeah. I want to go to the bathroom, so.
Okay. Well, we'll get started in just a minute. I wonder what happened to the projector.
Nope, not there.
That is peculiar. It's like it's like the light's really dim.
Yeah. Well, maybe your computer just shut it off thinking it wasn't in use or something.
We turn it back on. Okay, that's better. That's not good.
Have you changed anything in the last few minutes that would have?
I have not. Oh, maybe this got loose. Can we just?
Okay, Scott, there it is. You're back.
Okay.
Or you were for a second.
Oh, I'm still there. I got the Windows logo. Awesome. Well, I think we'll go ahead and get started. Well, thank you all for attending our May meeting. So our plan today is I got a few opening remarks I thought I'd make, and then we'll have Greg go over the space news, and then we'll hopefully do some time for socializing. We'll have a few more people rolling in, but we have quite a bit to cover. So I thought I'd get started. Plus we have quite a few online. It looks like we have about 10 people. So I've been interviewing people, a person a day since 2019. Oh, I'm not sharing? Oh, thank you. Excellent. Is that better? Yeah. Okay, cool. I've been doing a project called Countdown to the Moon, where I've been interviewing a person a day to find out what people think about us going back to the moon. And I've learned a couple of things. One is people are generally excited about us going back to the moon, but there's a lot of people who have some doubts about solving problems here on Earth first. Some have even said, we've made a mess of the Earth. Why should we take our problems and spread them to the rest of space? And then there's others that are kind of on the other extreme, saying that going to space actually helps us solve problems here on Earth. But as I think about this problem, there's a whole bunch of challenges and issues that need to be solved that both are necessary for us to save the planet and to explore space. And just to give you an idea of what some of those are, you know, being able to recycle water and to sort of shorten the supply chain around water, growing food, small scale manufacturing where you can actually manufacture things at the place of use with material that could be infinitely recycled, power generation and storage, and then telemedicine, and there's dozens of other issues that need to be addressed as well. But just focusing on the water situation, you know, right now we have like this huge supply chain for water. You know, it rains, the rain, you know, ends up in lakes and rivers. We divert that into water treatment plants, then we pump it miles and miles and miles into your house to be used precisely one time, and then goes to sewer treatment plants, and then eventually the cycle begins again. So lots of infrastructure, energy, and inefficiencies involved in the way that we address water. Ultimately, what we want to be able to do, and what we need to do in order to improve how we use water here on Earth and to make space possible, is to kind of shrink that cycle so essentially all happens within inside of our house. There's no reason why water couldn't be used multiple times in various systems. I mean, we even have sources of water inside the house that you may not think of, such as the condensation part of the AC that produces in the summer months here in Houston, at least, you know, probably tens of gallons a day of essentially distilled water, discounting the fact of any particulates that may have been collected on the, you know, the condensator. Plus, you know, I mean, we use the same water to wash our hands and to drink as we do to flush the commode. And obviously, we don't need all that clean of water to flush the commode. So why not reuse the water that we use from our hands to do that, so-called gray water. And then needless to say, we have issues with flooding here, but all the water that falls in our house, we immediately drain away, as opposed to saving in some type of local rain barrel or places. But the cool thing about this water problem is, you know, we already have some tech that can help, rain barrels. There's also this circulating shower, which I thought was pretty good. It actually helps you on the water side and the energy side, because not only do you get to reuse the same water over and over, it runs through a filter, and then there's some monitoring done to make sure that the water is clean, and if it's not clean, then it gets replaced. But you may not think about it, but all the water that enters your house that's used for a shower has to be heated up, and then you use it one time and it's only slightly colder than it was before. And it takes less energy to heat it back up to its original point than to heat fresh water back up. So you actually save energy there too. But, you know, as you think about this water thing, the cool thing about it is you don't need $100 million to go build a rocket to actually do something that would help space and the planet. This is something that the cost of which is actually in the reach of a citizen scientist, engineer, tinkerer, who can actually have an idea, try out that idea, test it, and actually get immediate benefit from it. Let's see. And so that's just kind of some thoughts I had around exploring space and saving the planet. But with that, we'll go into our news segment. So let me switch over to Greg's presentation, and we can hear about the latest space news. There you go. Oh, yep, that'll be good too. So we'll just switch over real quick.
Okay, well, I'll get started here. So This is the monthly space news covering the time roughly since the last meeting, about a month ago. And we'll just get right into it. There we go. So the first one is, first topic is winter is coming. Slightly delayed reference there, but it's coming to the Mars Northern Hemisphere. What does that mean? Well, it means that the days are shorter, so there's less solar input for the solar cells for any craft that are on the surface of Mars, which are still relying on solar cells. And there are multiple versions of those. Not so much the Perseverance rover, but some of the other things, which we'll get to here. So there's only two problems. One is the days are shorter, and the other is that there's typically more dust, and that's actually been a real problem for some of the craft that are on the surface right now. The big problem, of course, is you want to survive the night. You don't get sunlight during the nighttime, and they need the heat just to keep from freezing all the electronics. So what does that affect? Well, first of all, it affects the Ingenuity Mars helicopter. That's a pretty low power operation. They did actually lose contact for a while. It got cold enough that the thing shut down, went into a safe mode. And they waited around. They realized that when it started back up, it wouldn't know what time it was. And it was just going to start transmitting. And they had to make a point to stop and just listen really carefully. They managed to reestablish communications with the Perseverance rover, which is a good thing. That's really the only way we have to communicate with. All the communications are via the Perseverance rover. They did change the operations a little bit. They used to start heating when you got down to about 5 degrees Fahrenheit. And now they've switched it so that they don't turn on the heater until it gets down to about -40. And that's Fahrenheit or centigrade is the same. So that's a move to conserve power, and it looks like that's worked. So they're letting it build back up, and they think they still have good contact with the helicopter. It also affects China's rover called the Zhurong. They've scaled back their operations. And the big one, the one that's in the most trouble, is the InSight lander. That landed in 2018, was mostly for weather and seismic monitoring. They had a bunch of instruments on there. They've had a real problem in that the dust keeps building up on its solar cells. And a lot of the other rovers we've had, the winds eventually blew off a lot of that dust, and it wasn't so bad. But where they are, they're in this big open flat plain. There's just not that much wind. And so the dust just keeps kind of building up and building up. And they've tried tricks like dropping coarser sand, using the robot arm, dropping it on the solar cells, and then the wind that is there is used to help blow it off. And that's helped. But they don't really think it'll last beyond this year, maybe not even through the summer. We'll see what happens. So it's scaled back. On the other hand, it did come back from a safe mode in January, and they turned off almost all of the scientific instruments except for seismic monitoring, and which is a good thing because they did in fact hit or manage to monitor the largest Mars quake they've seen yet at magnitude 5 on their scale. So they're still hoping that they can make this lander last through the end of the year. Maybe it will make it, maybe not. Yeah.
Go back to the previous slide.
Yeah.
So why did the China's do one over operations back?
Well, they are based on solar cells also. So there's just a limited amount of power available, and they want to make sure they have enough to last the night. So that means they cut back on operations during the day, like driving, or maybe they don't use all the scientific instruments. So, and that's what they're doing on all of these. I mean, it's not unique to them, but they're all doing that. Next topic, nuclear thermal propulsion. This is basically, having an actual reactor in space. It is used to heat up a propellant, super hot, and it shoots out, so it comes out faster than it does from a chemical rocket. DARPA had done a variety of studies on this. Actually, NASA has done a variety of studies on this over time. Right now, they've already finished a phase 1 project, and they're advertising for proposals. So anybody in this room that wants to build a nuclear rocket, this is your chance, but you got to get your proposals in by August. So your time's a little tight. But they have a program, and this is sponsored by DARPA, Defense Advanced Research Projects Agency. These are the people that brought us the internet and a lot of the early automatic driving, kind of things. Typically, a lot of innovative stuff has come out of research that they have sponsored. And what they're doing right now is they're focusing on cislunar operations, meaning operations around between Earth and Moon. Their particular, interest, kind of from the military side, is if you have, some craft that are up there and need to go and do something in space, you may have very large orbital changes that are needed. And so they want to have a lot of power available, and they think they can do better, with an atomic-based one. what they're shooting for is something that's comparable to chemical propulsion in terms of thrust, but maybe 2 to 5 times more efficient. And so the propellant they have would last a whole lot longer as a result. They have an engine design already based on a project the General Atomics does. They're a contractor out of San Diego. They do a variety. They started off actually, obviously, in small atomic reactors. They do a lot of work for the Navy, also Predator drones and those kind of things. Anyway, yeah, proposals are due on the 5th. Now, I put several sets of pictures up here. The big picture here is the one that's from DARPA. It's sort of their concept of what something like this might look like. Quite often, you'll see this other one, the one over on the right-hand side over here, because NASA has a similar program going on. Their interest is not so much rapid maneuvering around Earth and the Moon. Their interest is getting to Mars faster. So they have a slightly different emphasis, but obviously they're still looking into the same kinds of technologies. But when you see that picture on the right, that's the one that NASA typically uses. Excuse me. To see the picture on the left, that's typically the DARPA project. Anyway, what's interesting about this one is they're actually hoping to get a demo flight in space by 2026. So they are moving along on this. Now, of course, we've talked about this a little bit before. There have been projects going on for quite a while, and we thought we were fairly close many years ago, but all those projects got dropped. So it seems like they're back in play right now.
Okay.
Yeah.
I think there might be a proximity issue with the mic and the computer. Like you might need to be closer to the computer for the mic to come through.
I'm sorry, what?
They're having trouble hearing you on.
Oh, the mic. Oh, dear. Okay.
I think
Sure.
if you're closer to the computer.
Oh, okay. So if this mic is not working then at all?
No, it's working.
Oh.
It's just,
Oh, okay. All right, I'll stay closer to the computer over here. Okay. Next thing is there are some other government programs that are of interest. In fact, they're very small businesses. The Space Force seems like they're, in a way, they're kind of getting their act together on doing things. They have this project called Orbital Prime. And what their focus is on sustainable space technologies and architecture to support that. So their overall goals are really two-part. One, of course, is technology development. And their big theme is called, they call it an acronym called OSAM, which stands for on-orbit servicing, assembly, and manufacturing. But there's a dual part to this. The other part of this is they see themselves as kind of priming the pump. They want to do things the way that NASA has done, for instance, with the CLIPS program for the moon and for commercial crew service. Basically get more small-scale private industry involvement. And it's kind of a dual goal there, sort of a business goal and a technical goal. And so, as their first project, they're promoting what they're calling active debris mediation. Essentially orbital debris cleanup. And one thing about this is they're talking about recycling or removing objects that are up there in space that are not wanted, for various reasons. The key word they're emphasizing here is non-cooperating debris. And that's very different. We've talked before about the Japanese company Astroscale, which is trying to put up satellites. They have a plan where everything that goes up, every new satellite, would have a little metal plate on it and then special some hardware and software to make it easy to mate with it and grab it and do something with it. But that doesn't really address, the thousands of objects that are up in space already. And so this actually, I think, this program is probably a lot more promising in that they're not assuming any cooperation whatsoever. A satellite could be dead, or any debris could be dead. It could be a piece of a rocket, whatever it is. You really need to solve the more general problem than just asking for things in particular. This diagram I have here, there's a bigger picture of this. Their idea of space sustainability, and I mean they just break it out into simple terms where you approach an object, you acquire it. Probably in most cases you grab a hold of it one way or another, and then you do whatever service is needed. Now that service might be repairing it. It might be recycling it or deorbiting it, whatever you're going to do. They don't put it on the slide, but one of their options is vaporizing it if it's a small one. So all those kinds of things, basically, this is the terminology they're using, and they're just encouraging people to propose programs to help out in this process. But again, their overall goal is having sustainable space operations. Now they do this they have a technology arm called SpaceWorks. And they have required the small businesses be a part of it and academics be a part of it as well. So it's kind of oriented towards starting off with small grants. You know, a lot like the small business innovative research grants that NASA and other government agencies have done. They just awarded a bunch of phase 1 contracts, 125 of them. That seems like an awful lot, you know, it's a very large number. But these are teams typically composed of industries and you know, academic partners. Each team got $250,000 to work with, basically promoting concepts and early design work. And that's about $31 million right there. They only have 150 days to come up with their proposal that they're getting paid for, you know, basically doing early design work. But more importantly, they'll be whittling it down, and then the phase 2 and phase 3 start, where there's actually much bigger funding. And in particular, their idea on the funding is it won't all be government financing, there'll be private investors involved as well. So again, they're trying to suck in, you know, taking advantage of some of the advantages we have in this country where there's a lot of private capital involved, just as has happened, you know, in a lot of other new space kind of activities. They want to tie into that really. Overall, they're looking at maybe $100 million kind of a project here. But they're hoping to have in-space demos within 2 to 4 years. So again, their timescales are relatively short compared to a lot of traditional space programs that happened in the past. Okay, and a little different topic here. Scientists, this is University of Florida, have now grown plants in lunar regolith. And I actually put in parentheses, despite lunar regolith, because if you read the paper, you can look at it here. I have it in the bottom of this particular slide. You can go get that. It's an open access paper. Anyway, let's go through the history of it. They've been trying to do this for about 10 years. And they proposed to NASA, you know, give us some of your soil, we'll try growing some stuff in it. And NASA, basically nobody was interested for the longest time. I think nobody really thought we were going back to the moon, so why bother? And now things are heating up again. People are getting interested in the moon again. So we're now getting the funding involved in this. So NASA funded them. And the funding included, well, money to pay for the research, but also it included giving them actual lunar regolith that was collected during 3 of the Apollo missions. They gave them 12 grams of stuff from 3 different missions and told them to, you know, do what they could with it. Now, this is a first, surprisingly, perhaps. You know, you think, well, we've been talking about going to the moon for a long time. Surely somebody must have done this before. Nope, it really hadn't been done. When we first came back from the moon, everything was quarantined, and they tried experiments like taking some lunar dust, you know, and sprinkling it on existing living plants just to make sure it wouldn't kill them. You know, so they passed that because they were worried about maybe there were pathogens of, you know, some unknown origin. So they got past that stage. But ever since then, there have been a whole variety of experiments growing plants in simulated versions of lunar regolith or Mars, you know, various other ones as well. But it's all simulated, not real. So this is a little different because it is actually quite different than Earth dirt, or, well, Earth soil for one thing. There's microorganisms in the Earth stuff. There's a lot of carbon materials. The big thing is there's a lot of elemental iron that you don't have in, you know, on Earth because it'd be oxidized and nothing else. A lot of the minerals are different, things like cadmium and that are really not very good for you. There's tiny abrasive glass particles, the thing that causes so much trouble with all the lunar exploration. So all that stuff's in there. It's a little different. And Johnson Space Center does provide an Earth-based volcanic simulant of lunar soil, but it's not really the same thing. It doesn't have some of those characteristics. So that's why they wanted to test it in lunar soil. So what they did is they planted the seeds. They put them in little 1 gram containers with water, nutrients, and light. And they have a particular plant they like to use. It's a form of watercress. It's in the mustard family. The reason they like to use that is that its genetic code has been fully mapped. And so if you want to see how do plants respond, they actually analyze it by looking at the gene expression. What happened? What did the plant actually do in response to its environment? It has the advantages also similar to many crop plants, and they have done experiments on the space station using the same plant. So they have a lot of good reasons for using this one. Now, the thing about this, though, is that really that regolith, it was not used for the nutrients. It wasn't used like regular dirt. It was basically just a substrate. Really, essentially, they're doing hydroponic growth. And it turns out that it will grow better. And you can kind of see this on the slide here. On the left-hand side of this picture, these are plants that were grown in the simulated regolith, and they did fine. And in fact, if you had it probably with no dirt at all, it would look even better. The actual lunar regolith, they could make it grow. So the amazing thing was, at least the lunar regolith didn't stop it from sprouting. It didn't stop it from growing. It did stunt the growth, however. And it obviously made them look very, very stressed. They could tell that from the colors. They could tell it by analyzing the DNA and RNA afterwards. So basically, they found that they reacted as if there were a lot of salts, which is probably true. Metals that were there that were really, a stress for them, and various oxidizing elements in the dirt as well. So it was stunted versus using the simulated dirt. And in particular, the other thing they found out was that these samples that the Apollo mission had taken were from various places. Some of them were, just on the surface, basically things that have been there for 1 billion years, soaking up, cosmic rays, in particular being bombarded by meteorites, micrometeorites. So it's been ground down to a very, very fine level, and the chemical composition has changed. They found that stuff was the worst. That actually stunted the growth the most. If you just took dirt that was, maybe from underneath the surface somewhere, you did better. So what their conclusion about, the only real conclusion they can draw is, if you're looking forward to, in the future, trying to integrate a lunar regolith, into something you're going to grow in, you're probably better off going for newer stuff like lava flows, going underground, that sort of thing. That was their main conclusion. Some miscellaneous topics. OneWeb, we talked about this before, because of the loss of launches from Russia, they were scrambling and they had contracted with SpaceX to do a lot of their launches. But they went to India, and they decided that India could launch a few of their satellites. The details are not out there, but at least they're not all going to SpaceX. Everybody is scrambling. Really, SpaceX is kind of the only show in town after Project Kuiper came along and soaked up all the other rockets that don't work yet. And that launch, they haven't even launched this particular rocket since 2019, so it's kind of a long shot. European Space Agency is continuing its replanning of missions that were also caused, the Russians had caused them great trouble because of the invasion of Ukraine. They had officially ended cooperation with Russia on all the cislunar missions, and they previously had already stopped. They had a Mars probe called ExoMars, or a lander actually, and that's been delayed to at least 2028. It might never recover really. But at least the earliest could be 2028. They need help from NASA for a couple things. First of all, the Russians were providing the lander on Mars for this, which is one of the hardest parts to handle. And they need NASA help for that. The other part is having the radioactive heating. We have these plutonium-based heat sources, which we use on the current rovers. Turns out that's not so easy to get those anymore, because the plutonium they used was a byproduct of nuclear weapons production, and we're not really producing a lot of that anymore. So they're saying, yeah, every 10 years we can build one of those. So there may be some other work that'll have to be done on this. Other smaller items: the Chinese had 3 astronauts up in their space station. They've returned. There were 4 private astronauts that had gone up on a SpaceX mission sponsored by Axiom. They had returned. And the International Space Station also returned for. So there's been a lot of activity going back and forth recently. One interesting side note is just showing how space-based stuff is impacting us more and more. There are now, according to Ukraine, 150,000 Starlink users. That is, users of internet service based on the satellites just in Ukraine. Now, it wasn't that long ago, there were only 150,000 users around the world already. So they went up pretty quickly. Now that's based on about 10,000, somewhere between 5,000 and 10,000 terminals. The current estimate is there's probably about 10,000 of those terminals there. So those went in pretty quickly, but it kind of shows you that even in the absence of a lot of Earth-based infrastructure, a lot of space-based stuff can start to have a real impact on the kind of communications with the military and civilian authorities there. Okay, now we're ready to talk about launches since the last meeting. Now, the last meeting, we didn't find very many. I think we found 8 or something. Well, it turned out there were 3 that just didn't get reported right away. So I'm going to throw those in here. So there's 3 more than normal. So anybody want to take a guess as to how many launches we've had since the last meeting? And launches means launches to orbit or beyond.
1 million.
You're too high. Okay, I'll go ahead. Actually, it's a surprisingly high number. It's 18.
20?
It takes 2 pages to get to them. I'll just highlight a couple of them here. I mean, most of them are pretty routine, like as usual, there's lots and lots of Starlink satellites that are being launched by SpaceX. One interesting one was that the Russians put up a rocket. It's called the Angara version 2. This is the first time they've made it to orbit. This project has been going on for 25 years. You know, their civilian space program is kind of struggling, and I would say that's an example of it. But at least they managed to get it up there. Oh, that's one. Another interesting one is on the bottom of this page. Is you know, China, of course, is launching more and more things all the time, all kinds of satellites. This particular one was launched from a barge at sea. Like, they're doing everything. They're launching from land, they're launching from sea. You know, anything that you think of, they've probably tried it. This particular one was launched from a big barge. Another interesting one, the Electron. Now, this is the Rocket Lab rocket. It's a small one. They're actually one of the few that have been successful so far in the small launch business, but they were not reusable. What they've been doing, though, they've been planning on catching their boosters, their first stage booster, with a helicopter and net. You know, basically they go out there, the thing's coming down in a parachute anyway, so it's not that hard to grab it. So they grab it in the net and in the helicopter, and they actually managed to grab it. But the pilot thought that the load was a little heavier than he expected, and he got a little bit worried, so he went ahead and dropped it. Now, they recovered it in the sea anyway, but their goal is to recover it in the air, so there's no saltwater contamination, no corrosion. So they're getting pretty close now. You know, pretty soon they should be able to pull this off. I guess, yeah, the Chinese sent up an automated cargo delivery to their space station. Otherwise, yeah, a lot of these things are pretty typical. One interesting one maybe is the Chinese had one failure. They have a variety of startups. Now, their idea of capitalism isn't quite the same as ours, but they are trying to reproduce what happened in this country with lots of small companies launching their own rockets. And they had one. This particular one is called Hyperbola. It's from a company called iSpace. They've had several failures, and they just had another one. Okay, any comments or questions?
So Greg.
Yeah.
What are your thoughts about the soil experiment that we did at NASA?
It's not about what?
About the growing the plants in lunar record.
Oh, yeah, I think they're gonna keep doing that. I mean, I think there's a little bit less to the story than it sounded like at first glance, because really they're just showing you can grow it. Just the fact that it doesn't kill the plant, I mean, that's progress. But the thing is, at least the lunar regolith apparently is not really outright poisonous, unlike the Martian regolith, where chemically it's really bad for you. But whether it can ultimately be groomed so that you can actually start growing stuff, you know, is to be determined. They intend to follow this up, obviously. Yeah, Charles.
Well, I believe, as you said, there's obviously no organic material in lunar regolith.
Probably not.
You know, there's never a source for it. So it's like, say, something to put organic material in. All plants, of course, have to store organic material to grow.
Yeah. So that's, but the hope is at least they can take, and they can use whatever's there. So that's just less stuff you have to bring from Earth.
So,
yeah.
So lunar regolith is essentially almost like saying,
yes,
like
glass. Yeah.
Like that, you know.
Glass and little elemental iron and just all kinds of odds and ends.
I guess plants have a very hard time absorbing anything, absorbing elements of iron.
Yeah. But I think what's going to happen is there'll be a big program to figure out, okay, this is what we have. What can we do with this so that we can minimize what we have to import from Earth? Ultimately, that's still, you know, you're going to have to do something. And even if you want to grow stuff out in space, you know, in large colonies or something, it's still cheaper to get it there from the moon than it would be from Earth. So you'd like to get as much as you can. Yeah.
On the same point, it seems like you said that there was a problem that a lot of the material was oxidated.
Yeah, I don't know what the compounds were. I saw reference to that in the paper, and I didn't.
Okay, well, was there any talk about just exposing it to ozone and basically burning that stuff up and turning it into various forms of rust?
Well, they didn't. Yeah, they didn't talk. They didn't go that far into, you know, amelioration of the problems. They were just their big thing was just highlighting.
Easy problem to solve.
Yeah, that one seems like it would be.
Just oxidate all.
Agreed. Yeah. Well, it means you do need oxygen, but yeah, if you got water there, you know, ultimately you got oxygen. So, yeah. Okay. I think we're ready for the speaker of the day, Charles Phillips. Now he's the head of his own company. He does a lot of research. In fact, maybe he's proposed projects with some of these government agencies before. He's worked on a space station and space shuttle. He also has been a flight controller at Johnson Space Center. He was a retired lieutenant colonel in the Air Force. He used to work as an orbital analyst for the Air Force, both in Cheyenne Mountain, NORAD, and also in Alaska. And he has degrees in space operations and physics and math. And with that, I'll turn it over. So this is from the days before color photographs. We had these.
Well, it's like from 1979. So how's the
Oh, here.
Did it stand close to this computer?
I guess I'll.
You know?
Yeah. This
And
is
there's no
Oh, it's the mic,
right.
that'll pick you up.
Right.
It's Bluetooth. It should. In
Right.
theory,
So I
work
should.
within
I'll just
40
stand
feet.
close to this here. So and this. Are you live streaming? This is our camera to look at or anything?
There's,
Okay. Right. Well, I'll look over there.
Actually, you can get on here if you want, unless my battery dies. You'll need this too for the.
Okay.
this
Okay.
forward
This
and
is
backward.
forward. Okay.
There's a laser pointer at the end here. Well, see if it works. Okay. You're just not quite that far out.
Well. Oh well, but I'll figure it out.
Yeah.
So forward, backward, important.
Yeah.
Well, sort of as a introduction, very few astronomers have a personality. I actually talk to them all the time. I'm an amateur astronomer, so I think I'm a kind of a rare bird in the astronomy business. Actually, can talk to people and explain stuff and things like that. So, as soon as we're ready to get started. Anyway, I think as Gary was saying, I've been doing the satellite tracking and stuff like that since 1978, which is quite a while, but various different people. I am, stand over here, I'm not leaning on you here. Now we're wrestling with our technology here, so
will the clicker take you to the next page?
it's not showing on the screen here though.
Oh, it's not showing the screen there. Let's take care of that.
Let's screenify it.
Actually, see that screen. I'll take this one back.
That'd be fine, sure. 'Cause I'll actually maybe look at the screen here, so. And I'll try to stand close to the laptop here so they can hear me, so.
But it's been really percent on that side, right?
That's my plan. And if I stand here, I get a suntan too, see. What do I do with my iced tea? Oh, there it is. Oh, there. Okay. Stand close to that. Oh, here we go. We're making progress here. So, yeah. And I have a little bit of a cough, but it's allergies only, I promise you, so. We're getting pretty close here. Hit the button and see if it'll advance page to page. That'll do it. Okay.
Okay.
This is not very bright. So if people have any trouble seeing it, please raise your hand. All right. What's that? It's okay. Anyway, so what I'm going to do is kind of dive into some fine detail that sort of give you an idea of why I do some of the stuff that I do. And so we're going to start with a fine detail, kind of like zoom out and kind of get a bigger, broader view after that. Anyway, so there's a bunch of people in the world that track satellites for fun. It's a hobby. Does anybody know that there is a there is a satellite catalog? There's a list of most of the really known satellites, and the U.S. government, and I'm kind of like jump ahead of myself here a little bit. The U.S. government kind of stumbled into producing that years ago. You know, that's actually where my career started. I actually used to be in the work for the Air Force, and we would track satellites and tell people where they were and a lot of stuff like that there. So there is a satellite catalog, there's a big list of satellites that the US government maintains, but that's not the only one. There's a bunch of them. Russia has their satellite catalog. There's some relatively private satellite catalogs, lists of satellites. Anyway, and I got into the group about 5 years ago, maybe, of astronomers, some professionals, some amateurs, and we track satellites, and I'll explain that in just a couple seconds. One of the reasons you track satellites is that if they get fairly close to the Earth, they run into the atmosphere primarily. They slow down due to drag in the atmosphere, friction of the air, and they hit the ground, which can be good or can be bad. This is a photograph here, I'm not taken by me, I think it happened in 2015, of a piece of a US rocket body, an upper stage, which re-entered and hit in Spain. And actually, so there's some significant pieces that hit the ground. And the US government, again, they have just decided to do it by themselves. They're the official US or the official world organization for warning people that look out, a satellite is going to hit you on the head. Look out, a satellite is coming in. So there's that. The UN actually has, they've actually said some agreements with the UN, so it's officially the UN announcing system, but it's based on information generated by really the US is the Space Force today. They have radar trackers around the world, and we can talk about that all day long. Optical trackers, telescopes, they track satellites, stuff like that. Anyway, but one of the things to remember is sometimes I think there's a pack of cigarettes, large metal objects fall out of the sky and there's no notice. Nobody is told. And why is that? Can you all read this all right here? Okay, so as I said, when anybody knows that there is a good chance of a large metal upper stage hitting the ground, of course, normally they break up in pieces and it's almost like a shotgun, you know what I mean? We should alert the public, It was on November 3rd, 2015, in Spain, a large upper stage re-entered, hit the ground, and there was no notice. Now, the US government, it's a Centaur upper stage, okay, which has been in space for several years, large, easily tracked, stuff like that. And this is a web page that tells more about that in case you're interested. Anyway, so people, this is not the US government web page, it's another group. Anyway, so people checked the official web page, which is a US government site, and said, well, what object was that? And there was no object that correlated. So why? What's going on there? That is odd. So let's take a look at this upper stage. Here's they recovered a number of pieces of it. This is a composite overwrapped pressure vessel. There's other composite overwrapped pressure vessels. So you can get serial numbers off those parts. You can tell what kind of an object it is. Obviously, it is a US government launched Centaur upper stage. We're the only people who do that. So I mentioned satellite catalog. So the US government, this is a page out of, it's a web page, of course, the satellite catalog. And it's at space-track, not underscore, space-track.org. And this is an example that shows, like you can't see it too well there, but it's like the columns, the satellite name, the type, the payload or upper stage or whatever, when it was launched, stuff like this. So if you look at the official, it's really the default official world satellite catalog, some objects have things like, and I can talk about the orbital parameters if you want to, eccentricity, inclination, stuff like that. So these columns give all the information, but there are some objects in this satellite catalog where all those numbers are provided, but there's quite a few objects where they are not. You know, so you look up and you can see there's an object up there, but you don't know what the inclination is. It doesn't give you the eccentricity, stuff like that. So we refer to these as off-the-book satellites, you know what I mean? So the US government, out of the goodness of their heart, I guess, started this. Here's the Aerospace Corporation is a federally funded sort of research organization, sort of like quasi-government. And they have the official page, I don't know if you can see that or not, aerospace .cords, that the official page which tells people if a satellite's going to re-enter or not. And spacetrack.org also has re-entry predictions. It normally, it'll carry all kind of objects, even very small objects that are not predicted to hit the ground. The Aerospace Corporation page is really sort of dedicated to objects which are almost certainly going to hit the ground. They're large enough, okay? So these off-the-book satellites, and we'll go back to I'll talk about those in a second or two, are usually not included in either of these lists, you know? And like I say, there are other groups in the world. It's fairly easy to track satellites, as it turns out, if you sort of know what you're doing, many of them. So other groups do maintain satellite catalogs and analyze, and so and I'm a member of that group, or one of the groups that that tracks these off-the-book satellites, many of them, some you can't. And we want to analyze this, but my hobby, I guess, is kind of figure out what is they're doing, why are they in their particular orbits, you know, stuff like that. So there are other groups that maintain their own satellite catalogs, and we take a look at those off-the-book satellites and say, why are they off the books? What are they doing? I hope you can see this all right. So kind of a busy chart here. And I know that it's on the web page here also, so I'll kind of describe it. And if you can't read this, you can go read it at some other point, you know. That top one's kind of hard for me to read even. So there's a group of astronomers. I'm an optical astronomer only, but also will like do radio frequency astronomy, who track these satellites and we maintain and I won't go into great detail. There's a lot of detail about that. Anyway, so the people that track these off-the-book satellites, because it's mainly a fun challenge. I mean, you can read that or not, it's a fun challenge. I will say, talk about challenge, I pretty much only track satellites in the winter time. Like this time of the year, I can maybe track once in a while, but the air is, you know, too wet, it's too full of moisture, there's a lot of clouds, so, and there's bugs, stuff like that, you know what I mean? So, you know, usually what I do is like, you know, December, January, February, especially right after a cold front comes through. I don't know if you all are familiar with this. Usually the sky will be clear, nice cold air, very still, you know, so you can really get out and get a lot of satellites then, you know. I go into a little bit of detail here. So first off, how are we doing? You got any questions out there? Okay, question. I will get into that in a couple of seconds. You can see them with your naked eye once in a while, but I use actually a very inexpensive digital single lens reflex camera. So most people use either video cameras, or I use a DSLR to get and I'll show you a couple seconds here, photographs of these satellites. In fact, I go out there almost very seldom do I ever see them naked eye because I'm just busy doing stuff, you know. But you go back to your house after a night of observing, you can only observe, I know I can explain this if you want to, in the dawn and dusk. At the middle of night, you can't observe for its whole, the way the light is, that's to be lit above you. I mean, the sun has to be lighting things above you, and you have to be dark. But anyway.
And do you have to go to these specific areas?
Pardon me, you gotta.
You have to go somewhere where it's not.
Well, this is a terrible place for optical tracking, terrible, location. So fortunately, where I live, right in my neighborhood, of course, you have houses, you have trees, everything like that. You can't see the horizon, but just right down, I have a little green belt in my neighborhood, and right not too far away from me is a practice baseball field. So what I do is I run out and I stand on the pitcher's mound, and of course the field has the trees are all kind of cut back and things like that, and there's no buildings. So the Clear Lake, I live in Clear Lake. The Clear Lake Observatory is the pitcher's mound of this baseball field. Not too far away, but just a 5-minute walk from the house. So we're here. So basically what I do is I go out and take photographs. There's a lot of people in the Netherlands, South Africa, a lot of other people around the world take these pictures. And we run them through what's called astrometry, which gives you the angles to all the objects in the photograph. You know what I mean? You run through astrometry software, and then I produce observations, which are the very precise location of where the satellite. And I'll go to it in just for a second here. And this guy, Mike McCants, who lives in Austin, just happens to be a guy who lives in Austin. So we all email him observations from all over the world, and he runs them through his software to produce the orbital parameters like eccentricity, perigee, apogee, stuff like that. Okay, and if you want, I'll talk about that in just a couple seconds. So is this working all right for people? Any questions? Okay. Anyway, so we track satellites. Basically, what it's by taking pictures of them, do some software stuff, send the stuff to Mike McCants in Austin, who produces orbital elements, puts them on his webpage, we pick them up, and then the process goes over and over and over, goes around and around. So we track stuff that's close to the ground, or for those near Earth satellites, like with a lot of, let me see, what did I say? We'll only talk about that just briefly. So let's go back to the whole idea of off-the-book satellites. So if you look in one of the satellite catalogs and you want to know the inclination of the space station, it's right there. Okay. You look in the satellite catalog, you want to know the eccentricity, orbital parameter for geosynchronous satellites, they're all there. Most of these off-the-book satellites, I think I put in here someplace the other, are all US government satellites. So there are some from Japan, stuff like this. Basically, they're military satellites, and they're satellites designed for photographic intelligence, electronics intelligence, signals intelligence. So they're basically spy satellites. Not a very good term. I don't like the term very much. But so these are satellites where the owners and operators of satellites don't want you to know the orbital parameters. So what they don't want to happen is you're doing some testing, or you're doing some development or training or whatever, and then when it's coming overhead, so you stop. You go up underneath cover so you can't take a photograph. You turn your radios off so you can't hear the frequencies you're talking on, stuff like that. So most of these off-the-book satellites are from our cooperating allies and the United States, and they're things like you've heard of the KH-11, KH-12 photographic satellites. There's something called NOS, or Naval Ocean Surveillance System, also called White Cloud. Another name for it is Parquet. So there's a bunch of satellites where the US government doesn't want you to know where they are, so you can't kind of cover up your operations when they're overhead and can observe you. Now that was a good idea back actually when I was first doing this, like in 1980, you know, but it is relatively easy to track these satellites now, and this is a feature. It's a it should have been long ago overcome by events, but it isn't. You know what I mean? Anyway, so we track these near Earth satellites like photographic satellites, like the SNOS is a ocean surveillance. It's it hears the radio and radar emissions from ships at sea, and you can locate them with that. So you can track those, and also deep space stuff like a lot of the. Do we know what a geosynchronous satellite is or geostationary satellite? So a geostationary satellite is one which is at a high altitude. Okay, so that and maybe I'll go into just one more second here, but the satellites rotate around Earth. Well, what happens if the satellite rotates on the Earth at the same rate the Earth rotates? Okay, so the satellite goes around the Earth in 23 hours and 56 minutes, whatever it is, same time as Earth. It appears to hang over only the equator. It's only over the equator. So a geostationary satellite is one that appears to hang over the equator because it is rotating at the same speed as Earth. We'll get to that just another minute if you want to. Anyway, so of course you can, any of those geosync satellites that are visible from Houston are visible. They hang there, you know, like a point. Anyway, so for some of these stuff like this, we track the satellites, and then the U.S. government, also Japan, Israel, several other countries, there are some off the book satellites, which you know, which the U.S. government also conceals the orbital parameters for them. So we track all of those, and then kind of speculate on what they're doing, and you know, stuff like that. For instance, they just launched another one of these ocean surveillance satellites, and in sort of the good old days years ago, they used to fly in groups of 3, you know, and what they did to triangulate from the 3 satellites, you would get radar from Soviet ships or whatever kind of ships at sea, and you could figure out from the time delay of arrival the exact location of the ship. Okay, so then after several years, they flew several of these triplets, and then they started flying pairs. I guess they'd figure out how to do time delay of arrival with just a pair of satellites. We've just recently seen one of them, but there's only one satellite this time. You know, so we're kind of speculating, is it the same satellite? Is it one of these ocean surveillance satellites that just is different, or have they figured a way to do this location with only one satellite? But anyway, so it's kind of fun to like track these satellites, and sometimes they're moving around and kind of figure out what they're doing, you know. So there's a bunch of people around. Ted Molkson, he lives in Toronto, Canada. Kees Bass is in the Netherlands. Greg Roberts is in South Africa. So we track a lot of these satellites, and we kind of email back and forth, kind of speculating about what they're doing and things like that. I typically am an analytical astronomer. I take the orbits that other people generate and run them through some software that I've written to kind of tell me what's going on. And I could get could get a little bit complex, that explanation. But I also do, like in wintertime, I actually do and observe as well. You know. So what do analytical astronomers do? What, you know? One fun project is I can plot perigee, which is the low point of the orbit, okay, to once the perigee gets down to a certain level, we usually talk in kilometers, so it is cool with kilometers, right? So the ISS, for instance, flies about 400 or 415 kilometers above the Earth's surface. The Earth's not at all uniform. but pretend it's a sphere for a minute or two. So about 400, 415 kilometers or 260 nautical miles, I think, something like that, you know. Now, when objects get down to like 200 kilometers or so, they're hitting a lot of significant atmosphere, and they slow down. There's a lot of friction, they slow down. I think the definition of re-entered is if you get down to 85 kilometers, you're essentially going vertically at that point, you know. If you're like a payload, you know, like some sort of a satellite or a upper stage, whatever. But a lot of them, of course, the smaller ones, when they get down to 150 kilometers, they're already going basically, essentially vertical. They're re-entered. You know, the big heavy guys will be able to like punch the atmosphere better. You know, the dense fellows. And if you saw that picture that Gary put up at first, one of the first things I ever worked on when I was in the Air Force was the reentry of Skylab. A few people know what Skylab was, you know, and it re-entered in 1979 and splashed all across Western Australia. And it really got me interested, and I've always been interested in re-entry since then. So what I do is each one of these points is a set of orbital parameters at a particular time, okay? And what you can do is, and each one of these points is, you know, 6 or 7 or 8 or 9 or 10 observations, okay? So what you can do is you can plot the perigee and if you saw a plot of the perigee for most things, so for instance, ISS, so perigee ISS is going to be a near straight line of decrease, but then they have various objects on, or, you know, various rockets they attach and they boost it back up. But most satellites are, let's say, at, you know, they're fairly close to the Earth, let's say 400 kilometers, 260 nautical miles or so. If they don't have an engine on them, the perigee will be like this, just as a relatively constant decrease, because it runs in the atmosphere, you know, as friction, and it pulls it down. And then as the perigee decreases, the apogee or high point decreases also. But anyway, some of these very interesting satellites, I won't go into too much at the moment. Some of the satellites are very high eccentricity. In other words, they have a perigee close to the low point of the Earth, the orbit is close to Earth, and the high point is higher. And some of these high eccentricity satellites, the perigee tends to have a sinusoidal change like this. And that is due, I won't go into this detail, this could be quite complex. It's due to like the effects of the moon, you know, pulling at the orbit. The orbit gets up pretty high. The geosynchronous belt, a lot of these, the apogee or high point is near geosynchronous height, which is about 1/6 the weight of the moon. So the moon is 6 times away as the geosynchronous, but the lunar gravity, the moon is so large in comparison to the Earth that the lunar gravity affects the orbits considerably, and that's primarily why some satellites have a sinusoidal effect on, mainly on perigee. Usually apogee, for various reasons, is fairly consistently decreases, but the perigee does zigzag up and down, you know, which is, you know, as a orbital guy, when you see something where the perigee goes up, you're thinking, that is really strange, you know, that, because these are, you can't really read it, it's like 250 kilometers or so, you know, I didn't bring my paper copies, but so to see something where the perigee recovers like this, that is like, what, you know what I mean? So, I don't know, made it be real exciting to you, but when I saw it, like, wow, it's kind of neat, you know? Anyway, so that's one of the things which I do is there are a number of objects which are off the books objects. So they will not be, you will not get a prediction when they're going to go hit the Earth's atmosphere and then the Earth's surface. And so one of these things, I track several of those, you know what I mean? And me and a guy named Joe Remus, he actually lives in France, and he can produce these pictures really well. If you can see this, there's the orbit the ground trace, and this is a predicted point for a high eccentricity object, which did, so there was one of these high eccentricity objects re-entered in 2015 in Spain. One entered, I think, the next year, 2016 in Mongolia, just for various reasons. I can explain it some other time. The majority of them will enter in the low southern hemisphere, okay, because they have the apogee set to where the apogee is over the northern hemisphere like this, because a lot of them are like electronics intelligence or signals intelligence, and then we'll look down over the Soviet Union and China, okay? So there sets the apogee high over like China, or a lot of them are communication satellites. Well, we use them in Alaska. And so the perigee be down here, so they normally re-enter in a part of the world with just mainly water. And so seldom ever hits anybody, but sometimes they do, you know. And there's a web page called the Space Review, and I've written a number of articles for that, you know, that talk about what these satellites are and things like that. So. Anyway, so in case you're interested, what kind of software and hardware do I use? There are a couple of programs like gPredict and JSatTrack. These are programs that this would, for various, you can put in various satellites you're interested in, and this will tell you what the observation windows are, you know, so you'd know when to go out. Obviously, so this is one satellite, you can see it here, it's above the horizon here. If you're taking pictures right there, you're not getting pictures of it. So, so I have some pieces of software so I can plan my evenings. I can go out and I can get, you know, this one and then get this one and get that one, you know what I mean? So and I set my camera up and I'm like madly dashing around, repointing it and stuff like that. So, and I use a, actually a Nikon D200 tripod, you know, my iPhone, stuff like that. I actually went and I got one of the least expensive, you know, but fairly quality. I got a Nikon D200, kind of older camera, but it pretty high quality lens. I want something that was, you know, when you take an exposure, you know the exposure. If you ever use cameras, anybody who's a photographer here with the camera, not necessarily the phone. Anybody got a camera? Okay, so you worry about the exposure, you worry about the shutter speed and stuff like that, you know what I mean? Most of these pictures, you cannot take them with a telephone. The telephone camera is pretty good, but pointing is very difficult, and then trying to get the exposure time. I'll get into that in just a couple seconds here. Okay, so you need a real camera, but you have to have something which is, if you have, I usually use 10-second exposures, okay? And I'll show that in a couple seconds. So, but you need to know the 10-second exposure has to be exactly 10 seconds. So you need a camera, you know, like a Nikon or whatever, that you know, that is built to fairly high specifications. Anyway, so I do my planning. I go out there and take pictures, and I actually have a web page, of course, that says how I do it. Anyway, so let's briefly talk about how do you get photographs, and we'll show some photographs. Cold front, very important. You know what I mean? Around here, there's a lot of, you know, chemical plants and the roads and a lot of air, like light pollution. You know, oh bad. So I can really start shooting like in November, and I'm shooting through usually like maybe early April. You know, so I set a very accurate time in my camera, point the camera toward the track of the satellite. I actually use an application on my telephone. I'd show it to you one-on-one. It's kind of hard to look at if you're interested. So I get out there, point the camera, and start taking pictures. I usually use 10-second exposure times. I usually start about, you know, some of these satellites were a little bit early, as we call it. They'll come through early or late. So I usually start taking pictures before the satellite is going to get. So I look at a guide star like Fomalhaut or somebody like that, or one of the, a lot of times I use, of course, the winter time, you can use the Orion, the constellation Orion, where the satellites in there like Betelgeuse or whatever. So you point your camera at that and they'll roll left a little bit or down or whatever. And then with the camera, with the object about to come through, you start taking pictures, click, 10 seconds, click, 10 seconds. And then you go back to your house after that and then put them on the computer and see if you get anything or not. Anyway, take the pictures. I use some software to get the exact time of the photo. I use this web page called Astrometry. And so think about a photograph of the sky with all the stars. Those stars have right ascension and declination, which are two angles, which says where they are. So if you want to look at, Betelgeuse or Orion or any like stars, Sagittarius, something like that, you look based on right ascension and declination to see where it is. Anyway, so then you see a lot of steps to get these observations. And several times now, the Air Force and now the Space Force will, some of those off-the-book satellites will appear. They'll start putting them in the web page, and sometimes they disappear as well. So this, hopefully you can see. So this is what you get from a photograph. This is USA 281, and hopefully people can see the streak. So you might have to get a little closer if you need to. So this is what I get from my camera. And then each of these, that astrometry, gives you right ascension declination, each of these stars, and I get the right ascension declination from both ends of the streak. So it's each one of those is an observation. Here's a Chinese upper stage, which is right here. You can't see too good, so sometimes I get pictures of, usually I try to concentrate on these off-the-book satellites, but sometimes I get other pictures of stuff. I've gotten pictures of ISS a couple times, it's just for fun, Anyway, so each of these photographs, and you can see the satellite right there, tells you where it is. And from these photographs, I get some lines of information, which Mike McCants in Austin uses to produce the orbital parameters. So if anybody has a question on orbital parameters, I throw this in there in case somebody has that question. The Earth, and there's like, like the orbital parameters, like the inclination. If this gray thing is the extension of the Earth's like equatorial plane, each object has a particular inclination, or how far off of the orbital plane is it, and is it round? Is it a round orbit, or is it like a long skinny? That's inclination, or that's eccentricity rather. And I think that's it. Yeah. Okay. So sort of to wrap it up, this is a sort of a hobby. Nobody that I know of gets paid for it. One thing I've tried to do some is convince the Air Force I don't really know anybody in the business anymore. I've talked to my email thing. I try to convince the U.S. government that a lot of these satellites that are off the books, that they don't release parameters for. This is silly. This is like, everybody tracks these things. You're not hiding anything. You're just wasting time, effort, and money. So stop that. But I don't know. They might at some point. Okay. So any kind of questions? Did I go too fast or anything like that? Or
Propulsion started.
what's that?
How did you get started?
That well, I've been interested in it since really 1979. When I was doing this, I did this professionally for the Air Force. But there, of course, we had tons of computers and people that did that, and software and radar. So I've been here for a long time, and I knew that these off-the-book satellites were there, and I knew some people were tracking them, and I guess I've actually been trying to start a business doing some orbital analysis kind of stuff. And I got talking to some people that do this. And I thought, gee, I wonder how could I do it? I wonder if I could do it too. You know, I hadn't done it in years. And so probably like about maybe really 4 years ago, I really got started and started, you know, borrowing cameras or bought a camera and stuff like that, you know, and then took quite a while to kind of work through the procedure. So there really is sort of residual interest in the whole tracking process and then an interest in some of these satellites and why are they still not on the books? Question?
So everybody got this picture covered at visit the government with some before us man in black that says that picture is up. Please don't ever report about that.
So your question is if anybody would come and say, don't do that?
Yeah.
I don't think so. They know we do it, you know what I mean? Having been in business before, I think actually there are probably a lot of people who are sort of glad that we are doing this to get some stuff which they want to talk about openly, but they can't, but now they can talk about us talking about it. So, you know, I think I was in the Air Force for like 28 years, and there's a lot of stuff that's secret, you know, but there's a lot of stuff that they kind of like, you know, that, you know, it's just no good, you know, like the capabilities that you have, you know, it's kind of good to be able to talk about them, even if you don't want to further acknowledge them, because that way you can talk to your opponents and stuff like that and let them know, hey, we could really do this, you know, so. But anyway. Right. So, okay. So let's go back to you. What's that?
Others want more satellites now in the sky being too crowded.
Well, so the question is the sky getting too crowded? And sometimes, yes, you know, I mean, we talk about the Starlink satellites, stuff like that, you know what I mean? Nowadays, quite often, if I'm taking a picture of one satellite that I'm interested in, I'll get other satellites in there as well. And I have to kind of figure out which is which, you know what I mean? So it isn't too bad right now, but people are talking about how maybe in a few years, you know, it might be so that you take a picture of like this, you get like 10 satellites in every picture, you know, almost, because there's so many constellations of satellites. So I know what we're going to do about that. Gary.
Seems like you have an awful problem with updating with more and more satellites. Like Starlink satellites might take a couple months to actually get to the orbit. They also have automatic ability for collision avoidance.
Right.
They make unpredictable moves. And then you have more military satellites, which also might be.
Well, you know, fortunately with the computers we have today, you know, when I started this back in 1979, the computer we did this with was, you know, I worked in the Cheyenne Mountain Complex. I mean, what the Cheyenne Mountain Complex is, underground command post in Colorado. It's kind of cool. Anyway, and the computers that did this were these big mainframes that were like way back there, and like these people, you know, it was, you know, you had to get special permission to go in the room and special permission to do this kind of stuff, and kind of stuff. It was like, you know, magic type thing. But you can do stuff with common laptops nowadays. You know, I mean, I do a fair amount of orbital analysis on my MacBook there, you know what I mean? So we can track satellites, and then I can email the parameters to Mike McCants in Austin and get an updated orbit really within a day. You know, I mean, hours if I needed it that badly or whatever, you know, but a day is probably usually fine. You know, so the satellites there, they do change their orbits due to drag mainly. Most things are hitting the atmosphere and slowing down. They slow, like the orbit changes, or some of them do have engines, stuff like that. So, but those, you know, again, that's a fairly slow change. So there's the chance of actually almost losing a satellite is very slim, you know. Okay.
I kind of have a hard time thinking about that. For example, this is a very huge project, and as you were saying, it's a very prolific topic. So there are some satellites on the book, and some satellites off the book. So probably 99% governments are taking the off the book satellites to see if someone is spying on them or something like that. So I'm just thinking that, for example, God forbid, if the gentleman in Austin passes away or something happens to him, what will happen to the community of these people that?
Well, that's a really good question. Most of the people that are doing this are really old people. Mike McCann is like 85, and Greg Roberts in South Africa, we're getting started. This is like nearly 90, stuff like that. So, I think there's enough of us out there that on this one particular group list, like you're saying, that if Mike decides to retire and stop doing it, somebody else will pick it up. Ted Molkson could do something like that. Now, I do know, the Russians have a semi-civilian satellite catalog themselves called ISIN. I forget what the acronym is. So you can look up and get these orbital parameters from most of these satellites from them. And of course, ESA has a satellite catalog, which they don't have on the web page, so there's just no access to it, stuff like that. I've been looking for a partner to help me track some of these other satellites for quite a long time, and I've been talking to a lot of people. I finally found some people in Ukraine, who had a satellite catalog, but their satellite catalog was, I don't know. I've never actually quite gotten where it started or whatever it is, the background. But I started talking to them, and I worked with them for about a year and a half or so, and really they're tracking more interesting satellites, all these off-the-book satellites, stuff like that. I got them doing that. And of course, the Russians invaded. With other, all these observatories. I think a telescope looks a lot like a cannon, so I think they put those away, and they're all locked away now. I know one of the people I worked with, Nadia, who was running one of the observatories I was working with in Ukraine, she's living with her daughter who lives in like Frankfurt, Germany right now, so, but anyway, so there are other catalogs, other people with very capable satellite tracking systems who are tracking these satellites. And if we lost them, we can just get them back from somebody else,
My other question is that probably all the satellites, they have GPS, so they can track where their own government, or I don't know, for them. So could it be more, I don't know, and you showed us a picture of a degree. So could it just be a kind of a business that you track the degrees with satellites that you have?
Well, there are a number of companies nowadays that do have fairly large distributed tracking systems, Numerica, Exoanalytic, Leo Lab, stuff like that. So there's several companies that do that, and they're trying to get business with people with satellites with payloads that are active satellites, and get them to help them with collision avoidance and stuff like that. Now, so majority of satellites are not active payloads. They are pieces of debris. They are maybe from explosions or whatever it is before. There are upper stages, stuff like that. So the vast majority of satellites are not active. There's no components. There's no GPS. They can't tell what their orbit is. You simply track them from the ground, normally with radar. I used to run a couple different radar systems, in the Air Force, and you could just sweep up everything out there. You know what I mean? Even down to like very small items. So they do it like a size of a ping pong ball. So most satellites, will not tell you where they are. You know what I mean? And there are companies which are trying, and I don't know what their business case is right now. They're spending a lot of money on tracking systems. So I guess somebody's paying, they're hoping somebody will pay them something at some point. Is there a question back there?
Yeah, we actually have a couple of questions online. David, if you want to go ahead and ask your question.
Okay, yeah, I was wondering if one, I mean, have you looked at the applications for AI in this? Can you hear me at all?
You probably have to. I know he's talking about AI. Maybe you can like just repeat what the question is.
Yeah.
Yeah, or you can read the text, the chat. But I was going to see if you had considered how AI might be used for this, and I can think of a few
Maybe you can
possibilities.
just repeat what he.
So basically, David
Uh-huh.
has two questions. One is, are you familiar with Zindo, which is an AI agent for visual tasks, which can be taught to identify and locate objects and images?
I am not familiar with that. I guess I could take a look at something like that. There a few people have some software to try to locate these streaks like this, yeah, nobody really uses that. Up until now, I should say, we've had so few. You can usually get a photograph like this with a streak, and that's all you need. So you don't need a program to help you find objects in there. At some point, if there were many objects, it might be good.
Okay, and then another question is, does objects rotation?
Yes. Oh, well, not my analysis right now. I'm actually proposing work right now to the National Science Foundation to do this with a video camera and to measure the rotation rates for many objects in space, and that not so much flash, but the variation of brightness over time. So we'd measure the brightness per time, and then from that get rotation rates, and they could see possibly if it's tumbling end over end, or if it's rolling, or different kinds of pitch, roll, yaw, what kind of rotation it has.
Okay, and I think FTL has done some work on image enhancement and look into black areas of lunar polar permanent shadow craters. I think that was more of a comment.
Yeah. That's probably a comment there. Yeah. The obviously what we're interested in is the streaks in the photograph. So.
David, did you have any more questions, or that did I cover?
Yeah. I mean, I don't know. Can you hear me at all, or is it? Am I just totally?
I can hear you, but other people can. I have that.
Yeah, I mean, I guess
You can
just
do
the thing.
some estimation of size. For instance, USA 281, due to the consistency of the streak and all that, and we can also figure the distance. So you can actually calculate an approximate size to that object. But it's like a fairly approximate, you know what I mean? So.
But it's not that far. For example, if it's going to hit someplace on Earth, you can estimate if it's something like this big or if it's something like
Right. Yes, from this we can tell that it's like maybe 10 meters long or something like that, that kind of thing, So we can sort of guess at the reflectivity of the surfaces. These things are not built to be non-reflective, you know what I mean? So if you look at if you go to like Space Center Houston for whatever and look at some of the rocket pieces they have there, and I've been to a number of museums and looked at them, they're all, most objects are built for the launch conditions, stuff like that, you know what I mean, for thermal control on orbit, stuff like that. They're often silver, which is very reflective, you know what I mean? So
for example, if they want, what are the techniques that they want to, they can use to hide the satellite, is making it non-reflective. So
yeah. The U.S. government did fly something several years ago called MISTY, which was designed to be a non-reflective, difficult to track by optical means, but it's very difficult to make things non-reflective optically and to radar as well. You know what I mean? So I think that particular object is not tracked well, or it might have been a failure or something like that. I don't know. And also, even for a lot of US government satellites and stuff like that, people have figured out over time what frequencies they transmit on. So you can always tell, like USA 281 when it goes by, people know to tune their frequency or their radios to certain frequencies. You can hear it talking to the ground. So it's hard to hide things in space because normally they reflect light, you know, you can track them optically. They often reflect radars, you can track them with radars, and also the active satellites, the ones which people want to hide, they transmit RF energy. And we kind of know in general what frequencies to listen to. Okay.
So just a random question, back in 2018, SpaceX launched a spacecraft called Zima, or, you know, apparently it never made the orbit.
Oh, right.
I was just curious, do you think conceivably it would be possible to hide a successful satellite launch? Or
Well, that particular satellite, our group did try to track for quite a long time, and we never saw it, you know what I mean? And we listened to it, and we kind of figured out, okay, what kind of frequencies, and they listened to those frequencies, is nothing. There was like, what was it? The name was like Zuma or something like that I remember talking about that a couple of years ago. You know, first off, when you're trying to track an object, it launches from the ground, you know, and at one time you could have launch sites which are like deep in China, which nobody could observe. But I mean, the U.S. launch sites, you know, Cape Canaveral in Florida, Vandenberg, California, Alaska, something like that, you know, or most of even the Russian, the Baikonur, you know, Placet, stuff like that. These days it's much easier to observe those, you know, and with a lot of the commercial, you know, like imaging satellites now, you could see where an object, when an object is set up on a launch, like for instance at Florida, you can take a sailboat off there, you can count every rocket on every launch site, you know what I mean? And then when they launch, there are always warnings that are issued, you know, for in case the launch fails and the pieces fall in the water nearby, or the Chinese even issue warnings, stuff like that, even though the stuff falls in China and frequently falls in occupied China. But also most objects have like the first stage, which re-enters very close, or SpaceX actually lands and recovers them. There's usually an upper stage which re-enters like halfway around the world, and generally I can talk about that for a long time. So you get a lot of re-entry warnings or navigational warnings for people like boats and aircraft to avoid these areas. So from looking at those warnings, you can tell the launch azimuth. It gives you an inclination. So it's very hard anywhere in the world to hide the fact that something's launched into space. You know what I mean? And from that, then you can predict a range of possible orbits and look for them. And it's very difficult to launch into space from any place on Earth and not have somebody looking and not fairly easily able to find that, you know. So
a lot of the military experiments from Russia and China, they end up splitting up. Like, what you think you have one launch, and it turns out one there's two. This one's going to be a target.
Well, yeah, sometimes the objects will like deploy other objects, stuff like that. You know, like the Russians a while ago had one, which is they call it the Matrosha doll or something. You know, which actually I think it deployed one, and that one deployed another one from that. You know what I mean? So you know, frequently I wouldn't track those. Now those would appear in space track. But let's say the U.S. government did that, and you know, does everybody know what the X-37, it's like a little space plane that the U.S. government flies, the Air Force or Space Force, yes, flies that now. It's kind of like a little bit tiny, like 1/3 space shuttle. It doesn't have people in it, but they've been flying the X-37 for a long time. And people have speculated that the X-37 has released payloads, you know. Well, so unless you put a honking big engine on there, if you released a payload from almost any kind of an object, it would be very close. It would essentially, it more drifts away than anything else. Unless a big engine flew away real fast. So if you saw a picture like this, and if USA 281, if it deployed another object, you would see it parallel on there, and you could get the orbital parameters for that. In fact, I mentioned this naval ocean surveillance satellite. I've gotten a bunch of pictures of those, and those fly parallel like this. So you can always tell a picture. I have several pictures, not with me, I don't think. You can actually see both objects, you know, so you see two streaks. Now, if it deployed something and you couldn't observe it for, let's say, a month, it might drift so far apart that you wouldn't be able to connect the two. But you know, it's normally you'll see everything. You know, somebody around the world will see something every 2-3 days. So the whole idea of trying to deploy something which then flies away and is hidden it's possible, but difficult.
Are you tracking things as far as the moon? There's that one piece of rocket that nobody owned up to, it's supposed to crash into the moon.
Well, we don't. Most amateurs that I know of don't track those. There is a group, the Smithsonian or whatever it is. There's the Minor Planet Center. So there is a group, I think it's run by Smithsonian Astronomical Observatory. So there is a webpage out there that lists like 20 or so, like Apollo, you know, like upper stages, which were where the capsule detached from the upper stage in a lunar transfer orbit. So there's actually probably like 20, 25 objects, I guess, that people are tracking that are like in the lunar transfer orbit, a couple of Chinese upper stages up there. And so some people do recover these anything beyond geosynchronous altitude for us is very deep space and very hard to track, even for the US government or any government. So people have recovered some of those objects, but it is a very chaotic type orbit, very hard to find, very hard to follow, stuff like that. So there's a lot of interesting work in that area. But again, that's very challenging to try to keep track of stuff up there. Okay. Well, I guess I will let you go. It's been a great pleasure, you know. I hope everybody, if any questions, you know, get hold of Nathan or get a hold of me and I'll try to answer your questions.
Well, thank you so much. Really glad that you were able to come and talk to us.
Sure.
And definitely very interested in satellite tracking myself. I did have sort of 3 things I wanted to mention. One is tomorrow night is a lunar eclipse. And in addition to being a lunar eclipse, there is also, there we go. It's the open house. It's coming. Yes. So tomorrow night at Rice University, they're going to have an open house at their observatory, and you can see the lunar eclipse, assuming everything's good, and they're going to have a talk at 8 o'clock. So if you're looking for something to do Sunday night, that's one option. And also next month, our next meeting is Saturday, June 11th, and we're going to have it at the library, actually. So it'll be a little, it would be our original setup that we had before COVID. So it should be good. And the third thing I want to mention is I have a whole bunch of ad astras in the back. If you could take several, that would be great, because they would definitely be a lot better out in the world than sitting at my house. So with that, thank you all very much. And I'll go ahead and leave the meeting, but I'll leave it going in case y'all want to talk online. So David, I think I'll go ahead and make you a co-host as well. And I'll go ahead and disconnect, but thank you all very much for joining.
Okay, yeah, can you hear me now, Nathan?
I can hear. I have you on a headset though.
Yeah, yeah. Well, let's tag up some time and see what we can do on making a few little improvements on this. I'm working with a couple other groups, and in fact, the NASA Alumni League was maybe going to join this one because they're wanting to start doing hybrid mode for their monthly meetings.
Well, it sounds great. Yeah, I'll follow up with you on that.
Okay, yeah, got another group that's been doing them, and they've got speakers and stuff that they bring into a restaurant. So yeah, there's some good, I think, low cost options that we can get.
That sounds
Okay.
good. Okay,
Well,
well, we're gonna sign off here in the room.
all right. Well, if anybody else that's online wants to stay on and chat, I guess, or